Welcome to Electric Vehicle Television. I'm Jack Rickard, and I'm here with Bob Wilson. How's your week, Bob?
It's good. I'm a birthday boy yesterday, so it's been a good week.
You've been here. Yesterday was your birthday?
Yes.
And how old are you?
49.
49.
Yeah. Or should I say
49?
29 again?
49 trips around the sun.
Yeah.
And you've been at here. This is what is today?
Well, it's the 27th,
27th.
so pushing a month.
Yeah, pushing a month.
Yeah.
What do you think of EVTV?
I love it.
A lot more going on
Yeah.
behind the cameras than
Oh
you
yeah.
think.
You know, it's fun. You know, I mean, it's everything I came for, really. It just is.
And the screaming and yelling and throwing all the
You
tools,
know.
that's just like gravy, right?
Yeah, this guy.
On top. Yeah.
You
That's
know.
just gravy. Have you found any electric vehicle news this week?
I sure have. I got a few
Anything that
tidbits.
strikes your fancy?
A couple, and in fact, I don't think I have any Tesla news. So
You know, it was kind of a light
kind of
week.
a
on
quiet week for
stuff.
Tesla, yeah. But I do have. I'm going to start out with some Chevy Bolt information. Chevy Bolt has 55 pre-production cars that they say are exceeding the 200-mile range. So after recent shots of the Chevy Bolt testing in GM's Milford Proving Grounds, they decided to get ahead of the news and give an update on the program itself, to kind of quell the speculation. So there are 55 pre-production Bolts now in existence being put through their paces.
And they're actually achieving 200 miles?
It's what the headline says.
Okay.
Yeah. I didn't call GM and verify any of this, but yeah, they have over 1,000 engineers on the job. They're being hand built in their Orion plant in Michigan, as well as their South Korea plant, where the Spark is currently being made. You know, they're going through, like I said, the paces of all their quality checks. So the miles, the comfort, the ride. Charging performance as well. So they have a DC fast charge. And they expect production to begin in October of 2016 and arrive in 2017 as a 2018 model vehicle. Yeah.
So it's going to be at least a year.
And they expect it to be at
1,000
around
engineers
30. Yeah.
on 55 prototypes.
Yeah.
Hands-on. So,
A little crowded, huh?
So that would be, what, 20 per prototype,
Right.
each working on it. They do know how to throw a lot of resource on top of a thing.
They sure do, yeah.
And
No
I
stranger to
think
overhead.
that Chevrolet has decided that not the Volt, but the Bolt is their lightning bolt to wedge this market.
Into the electric space, huh?
They have a guy who is the chief engineer for the Bolt named Josh Tavel. And then, let's see, the executive chief engineer of electrified vehicles is Pam Fletcher. And then who's the head of the company? It's another woman that introduced it at the Detroit Auto Show.
I apologize. I don't know the lady's name, but
All
yeah.
three of them
I just have
were
GM's.
chanting the same, almost pre-recorded sounding mantra.
It's their boilerplate, I'm sure, that
And they've got their talking points down with some great discipline, and they're very uniform in that the Bolt is not an elitist $100,000 electric car that nobody can have.
Yep.
It's the car for everybody.
for the masses.
For the masses.
They expect it to be around 30
This
grand.
is their counter to Tesla, and the way they're going to go after this is with a 200-mile cheap car for everybody. And that's, I think they're going to have a little trouble competing with all the used Leafs that are out there.
Going to be interesting, isn't it?
It is, but that's how it's shaping up. Is that's their their big play over the next couple of years. As I've been saying, we have this, and I've gotten a lot of grief from some of our viewers about not being a real EV advocate because I'm talking about the depreciation of these cars. There is something that's come up in America today that if you are in favor of something, you become an advocate, and that means if anybody has anything negative to say about it, you shout them down.
Yeah, you know, you're a spin master.
You're a spin master. They're all spin masters now. Who can spin the best?
We like to keep it real
here. And they
here.
learned this from the politicians on the wider media television, and that anything that is a plus, you exaggerate beyond all concepts of reality and repeat it a lot.
Yeah, yeah.
And anything that's a negative, you simply shout them down.
Yeah.
And call them names until they go away.
Yeah,
and
they shame you away.
Or they shame you away. I would offer another alternative, and that is that you consider things as a sentient being, use a little bit of critical thinking, and if you are in the business of the media covering that you kind of just report what's going on, and it's okay to offer what you think that means, but you don't just ignore it because it doesn't adhere to the party line that comes down from corporate. We don't have a corporate, we don't have a party line. My EV credentials are really at this point mostly under question by people who don't have a clue about electric vehicles.
Go build one and tell us what you think.
Have just shown up on the scene and decided they're an advocate. We've been building them for 6 years, pretty hard, like 7 days a week. And yeah, we're in favor of them, but what is what is. And if you're going to play in this space and want to do well, you have to have the info on the reality of what's going on.
Yeah.
And we're going to try to be about 60 days out ahead of everybody with that. I can't really see the future, but I can see about 60 days further than most people. And so that's going to be for your benefit. I'm not real keen on telling you what to do with the information. Just here it is. And they're coming in the email box over the transom in waves. Thank you. I just grabbed a Leaf for $9,000. I just saw one on eBay for $3,000.
Yeah.
Apparently the 2011s are real bargains.
Yeah, yeah.
There must be something uncool about 2011s.
I don't know that it's the
It appears
actual
2012
price.
is the one to have, but they're going cheap. The Volts are as well. There's deals on Volts, and both of these guys are bringing out new product in the future that's going to make these cars depreciate even more wildly. I think we'll look at a 70-mile Leaf in a couple of years and laugh because all of them are going to be doing 200 miles. Carlos Ghosn was doing a shareholder presentation in Tokyo this week and showed a video of a Nissan Leaf showing on the dash 544 kilometers remaining. That's about 330 miles. And right now, the 2015 has an EPA rating of 84 miles. And yeah, they were, it's kind of widely expected that this year being for the 2016 model year, which starts to roll out typically in September, this being the 1st of July near enough. So we're talking 60 days from now.
Right.
That we'll have a Volt with a 20 kilowatt pack instead of a 16.
Right.
And a Leaf with a 30 kilowatt pack instead of a 24.
Yes, and I think we reported on that.
So they're bringing out better cars, at the same time that there's this huge number of cars coming off lease, and still several thousand Chevy Volts 2015s that have gone unsung and unsold. And so to me it looks like a perfect storm of huge depreciation on the cars that makes a new electric car look extremely undesirable.
Exactly.
As we talked last week, you can get more for a used Versa than you can same model year Leaf, and and so that's not a good concept to buy a new car on. Not a bad one to lease it on, though.
Yeah, $100 a month.
Well, here's this downward spiral, which the car makers get in on. They're not going to be able to sell a new Volt or a new Leaf at all.
Well, that's kind of why they came up with that lease program anyway in the first place, right?
Well,
to get the adoption.
It's kind of addictive because now I think most of the new car buyers would be wanting to lease and get even better in 3 years without having to worry about the depreciation.
Yeah.
Doesn't that make sense?
Right. You have a guaranteed trade-in value and walk away, or
when you have a much higher lease rate, that causes more cars to be coming off lease in 3 years. You see the spiral going on.
Snowball.
And so the car for the rest of us may not be the Bolt. It may be the 4 or 5 year old electric car that is virtually you're not going to be able to give away.
Yeah. And they're still nice cars.
But still a few puffs left in that cigar butt.
Right.
You know, I think the batteries are better than even I expected, is what's coming to light. And we've been playing with the Better Place packs, and I love them. I don't understand them, but I love them.
Yeah.
And we've never touched the BMS in anger.
No, we just kind of
Haven't
use them
balanced
for their
anything
bulk
or
voltage
monitored
and
anything.
right. We just use them and charge them. Yeah.
They just seem great. As we reported last week, there's a taxi driver in the UK with 100,000 miles on a Leaf.
Yeah.
Still showing 12 bars. And so we're gonna. So it's kind of a perfect storm all happening at once. I guess I don't see them just pulling out this fall when they've got all these plans, but I think their new car sales are going to be abysmal. One guy assured me that the car sales were up. Well, they were up from April to May.
Right.
But they're down 100% from last year.
They were, yeah. That actually, that
They're
first
in the
4
toilet.
months was pretty low.
And the hybrids were worse. And so it's not all good news. And I would be wary at this point of buying a new electric car. I feel kind of dumb for having bought the Model S. I could have leased it and traded it on an X.
Yeah.
You know. But so lease is probably the strategy and these guys, when they can't sell their cars, offer pretty attractive lease deals. That's the way they deal with it these days. And so $99, lease on a Leaf was apparently
Pretty good
play.
deal. Pretty good deal.
And you don't have to keep the car. At the end, in 3 years, things have changed again. And we could be looking at 300-mile cars. So is it a positive or negative? It is what it is. I think it's a bloodbath for new car sales as word of depreciation gets out.
Yeah.
That's going to lead to heavy discounting on the lease side, which is where you want to be. But if you want to own an electric car, you buy them off the back end, and it's raining electric cars.
Raining cars, yeah.
Yes, I'm an EV advocate. We also sell components, and
Yeah.
I'm heavily involved in that. But right now, we're kind of drying up. Everybody's putting their extra Ducats into buying up used Leafs and Volts.
But let's be clear, you don't get the
done it.
satisfaction from a Leaf as you do from building your own conversion.
I'm panicked, but not very much. What a lot of people understand is I call it the low-hanging fruit, and I mean nothing derogatory about that.
Yeah.
But many of our viewers have built 2 cars, bought 2 cars, and would be in the market for an electric watermelon if I'd show them how to plug it in. Once you get on the electric gig, you want an electric boat, you want electric everything. You don't like that noise. You don't like that smell anymore. And that roar of the big block V8 just loses its romance.
I'm zipping along through town, and it's quiet, and and you hear this big clunker cruise by, or a big diesel stinking the place up, and I can just zip right past them, And so
you'll have to take the speedster out. There's nothing like pulling up right next to the exhaust pipe at window height.
Oh, yeah. No thanks.
Of a big Dodge Ram diesel with a Cummins diesel.
Right.
Belching
that sounds
black
like a semi.
Stuff right in your face. Right?
Take that, Evie.
That Evie. And they do. So that's where that's at. I'm also confident that good things are happening with batteries.
Yeah.
What's your story about 24M?
Yep. I got a little bit on that, as do you. So 24M is a spin-off of A123. A123 went belly up a few years back, and 24M was founded by the what's his name, Yet Ming Chang.
It's not really a spin-off of A123.
Okay.
Yet Ming Chang is a professor at MIT.
Okay.
Or he was.
Which, Waltham, Mass.
And he came up with a concept to use a nanopowder version of graphite in a lithium iron phosphate cell. And that was funded and developed into A123.
I see.
A123 went broke.
Right.
They had some really stupid business practices. We had to buy our A123 cells from China.
Yeah. Who was that, like the third owner of them,
and
right?
And some mechanical issues. Their packaging got to be a problem, and they faced this huge recall that just wound up breaking them.
I see.
So they went broke, and Wang Zhang, which is a big Chinese parts company, bought them and bought Fisker, and I believe Fisker used their batteries.
Oh, I see. Yeah.
So you see where that's going.
Right.
The founder has started another company.
24M.
They've been in stealth mode. They got pretty good funding. What did they get?
50 million. Yeah.
$50 million.
They've got about 50 people, and they've raised about 50 million, and they've so far made 9,000 sample batteries.
It's a completely new company. It's not really connected to A123, but it's the same founder.
Other than that, yeah. Okay.
And they've come up with a new battery concept with serious promises.
Yeah.
Now, I can be skeptical about
Press
battery
releases.
things. There's a lot of battery announcements
Fluff.
that we don't even mention here.
Yeah.
Because they're so silly. This is not one of them. It's real. He's talking about cutting the manufacturing costs and the inactive materials from the battery.
Yeah.
Quite dramatically. They're talking 2 to 3 years to get this on the ground.
Right, 50% reduction.
They're talking about
in
a
cost.
capital cost for the machine that makes the batteries of about $11 million.
Yeah.
About $160 per kilowatt hour. And that by, what did he say, 2020?
Yeah.
And that could be down to $85 a kilowatt hour.
Pretty remarkable.
Let's take a look at their video.
These 2 lithium-ion cells look exactly the same. And yet one costs 40% less and stores more energy. Looking inside a conventional cell, we see a myriad of metal and plastic layers that have plagued the industry with high costs for 25 years. As shown in these actual cross-section images, the revolutionary 24M design strips away more than 80% of this excess material. We call it semi-solid lithium-ion. A better design, a better battery, a better energy future.
This is all kind of real, guys. What his main discovery is pretty straightforward. Lithium iron phosphate as a cathode material has a serious problem. It doesn't conduct. It's an insulator. And you can't have a cathode that doesn't conduct.
Insulates, yeah.
The workaround is to mix carbon, which is a good conductor, in the mix that you put on the cathode. And when I talk about him putting them on the cathode, this is kind of part of what he's attacking too. You take a sheet of aluminum and you mix these magic powders together and you stir them in with a binder, kind of a gelatin-like thing that dries. Picture a glue that doesn't really hamper the conductivity too much. And you basically print it on the aluminum foil. Now, since it's all covered, I guess you wouldn't call it printing because there's no letters and spaces. It's all covered,
Right.
like a paint roller. But really, the process is more like offset printing with rollers, and it goes through a machine that's like a printing press.
Right.
And it prints this solution of particles and binder on both sides of the aluminum. Well, then you have to dry it. And then you have to cut them into the squares that you're going to put in the battery. And then on the other side, you take copper foils and you do the same thing with graphite on the copper ones. And again, carbon, really from coconut shells, burn up real bad, is mixed with a binder. And I call it smearing them on there. But picture an offset printing press with rollers.
Right, I think it's a silk screen kind of thing.
Yeah, like a silk screen thing. But again, you're not screening anything. The whole thing gets the thing.
A certain thickness.
And then, but then you have to dry those. And understand they're printed on both sides. So how do you do that?
Challenge.
And you can't do anything to them until they're dry then. And so
traditionally.
And you wind up with a battery that is mostly a copper and aluminum. Now, you'll recall many of you were excited about the A123 cells. We actually sold them for a while. I had various strategies to make them into a battery, none of which worked very well. Although I still have some cast urethane batteries floating around that we use for 12-volt batteries. And they've just lasted and lasted. And one of them,
I didn't realize those were A123s.
Yeah, one of them nearly burnt the shop down. But since that one, we've used them and they just last and last and last. I'm really quite surprised. But the notable thing about the A123 cells, 19 amp hours, but they could do 60 C output. Now, how could they do that? Here's how. Yet Ming Cheng came up with this, essentially a cheap way to make nanopowder graphite, and put quite a bit of it in the cathode, making it much conductive. If you make the cathode thicker to give it greater capacity, that cuts down on the ability to diffuse current through it. Because the lithium ions have to migrate to go in and out. And of course the electrons do too. and they have to go along the graphite plane. Well, by adding this very small particle graphite, he cut the diffusion resistance,
Internal.
basically, and allowed much higher current levels, although he did use a thin layer of this stuff. Now, follow the line of reasoning what 24M is coming out with now. They're basically not going to have all those anodes and cathodes.
Right.
Here's an anode and here's a cathode, current collector. And then we'll have a thick layer of graphite on one, carbon on one, and lithium iron phosphate on the other. Well, isn't that going to cut down on its ability to deliver power, increase the equivalent series of resistance because of diffusion? Well, not if you dope the hell out of it with that graphite, just like you did the A123. You might not get 60C, but you might get 6 or 10.
Which is pretty good.
Which is just fine.
Yeah.
And now your anode and your cathode are, 30 times thicker than they were before. And we don't need all those individual
Envelopes.
Foils. We have one current collector on the front, one on the back. We got one separator. We just knocked out 30 or 40% of the inactive materials of the battery.
Yeah. In fact, it may be more than that.
Maybe more.
What did I read about that? It was, I want to say 80%. I think it's they knocked out 80% of the build time.
And so this was a bright guy who came up with an excellent way to put a lot of power out from a pretty small cell.
Yeah.
And now he, and of course their business model failed and their mechanical engineering really kind of failed. But you can still buy 1, 2, 3 cells from China. Wang Chang's making them.
Okay.
So it's not that they weren't a good cell. Several people have made cars run on those cells, and I don't know of anybody that's happy with them.
Oh, is that right?
Yeah, it's just kind of hard
Not as advertised
to
or
put
just...
all that together. I mean, if you take a look at what you have in a Volt or a Leaf, that's basically what you need to do to put together, 3 of these cells in parallel and 96 in series. It's a lot of stuff.
Yeah, to actually make the package, the pack.
And it to be sturdy.
Right.
And so I don't know anybody that's really been happy with those. But this is a variation. This is taking exactly the same technique a different direction. Instead of huge power output, how about better capacity?
Sure.
And less inactive materials and cheaper to produce.
Way cheaper.
Way cheaper.
Like 20% of the cost.
Right.
Yeah.
So, just a lot of steps are out of it.
5 steps, I think you said?
You don't have the binder. And you don't have all the printing. They're kind of cakes of stuff.
Right.
With a current collector kind of holding them together.
Yeah.
And so it's a completely different process.
Yeah, they go from days to hours, start to finish.
Right.
And so there's no, like you said, no drying time.
They're talking about a device the size of a refrigerator that can make these batteries, and the device costs them $11 million.
I'll take 2.
Which is relatively inexpensive for capital equipment to do that sort of thing. So I think that is a big possibility. Of course, everyone is the Bolt, and really most of the OEMs are going with LG Chem with their new kind of NCM type cells, looking for the 200-mile car. But Samsung has also announced this week a new battery technology. And Samsung is non-trivial. They actually are a large battery manufacturer in their own right.
Oh, they're
not to the size of Panasonic, but a good number 2.
They're legit.
And huge.
Yeah, that's what I mean.
And they They make and sell batteries now by the Brazilians. What they're talking about doing, one of the holy grails is the silicon anode. And everyone's talked about this. Panasonic has been supposed to have a silicon anode any minute now for several years. Here's the problem with silicon anode. Here's the reason they like them. Here's like, I'm going to make up some numbers, they're not right, but like the maximum density of intercalation of lithium ions would be about 378 milliamps per gram with carbon.
Okay.
It's like 1,400 with silicon per gram.
Right. Right.
So it's
Four
easily
times, let's just
four
say.
times the capacity for the same weight of material. Now here's the problem with carbon. When you intercalate all those lithium ions, it changes volume. There's no chemical binding here. There's no chemical process. This is an intercalation into a crystalline structure. The lithium ions still have their own identity. They're not bound to anything.
Right. They don't
Right.
chemically change.
They don't. There's no chemical change goes on here, but there is a pretty big volumetric change because it swells the crystal
Okay.
by them being in there. You've added material to the crystal. In the case of the silicon, you've added 4 times the material. So what are you going to do to the volumetric expansion? About 4 times. And it's a problem. And silicon, of course, breaks up. It's kind of like glass. And so you're breaking the glass.
Yeah.
And so it's very easy to make a very high capacity silicon lithium iron phosphate cell.
10
Or
times.
silicon and lithium cobalt. Yeah. It doesn't really care which of the available chemistries for lithium ion you use on the anode or cathode side. And so, but it swells a lot. How do you deal with that? Samsung claims they have come up with a process of wrapping the silicon anode with sheets of graphene. Kind of like
The magic
curtains
material.
that slide
Okay.
to expand to accommodate the silicon, and these sheets of graphene are very, it's like graphite.
Pencil. Yeah.
It's very slick.
Lubricant,
It's
yeah.
lubricant. Mm-hmm. But these are single sheets of graphene, kind of in layers, like multiple curtains in a movie theater or something.
Mm-hmm.
And so that contains the silicon while allowing the lithium ions to pass through the graphene, and so contains the volumetric change in the silicon.
We'll
Now,
see,
I don't know what that means. Apparently, the big issue is to do that without forming silicon carbide or graphene carbide, silicon carbide. And they've got a way to do that, and they claim.
They're working on a way.
No, they claim
They've done it.
they've
Got her
solved
done.
it.
Okay.
And so this is only 2 or 3 years out to be able to make a silicon anode battery, which realistically, are they going to get 4 times? No, they're not going to get 4 times, but you could easily be 2 to 3 times the capacity in the same volume and weight
Which
of
is a good
material.
thing. Now,
which
how
would
about
be
longevity? That's
The longevity is the whole issue.
yeah.
The silicon can already do the capacity. The problem is get it to do it 12 times in a row. And
Let alone 2,000. Right?
let alone 2,000. And as it would break up, the capacity fell off heroically. I'm thinking that what most people were getting was like 35 cycles or something. Maybe under extreme things with some of these gelatin, kelp, materials 100. Well, we can't live with a 100 cycle battery.
No, no, it doesn't
No
work.
market for that at all.
That's it.
Nobody wants
No.
that battery.
Not even in your flashlight.
Well, flashlight, you get them where you use them once, or they're rechargeable. If they're rechargeable, 100 doesn't do it. You know, and so this is kind of big news. So we're suddenly seeing two fronts with some very credible people who are known units in the battery ecosphere.
Yeah.
With some very exciting news.
Yeah, these are good positive steps forward.
So I'm kind of jazzed on both 24M and that's gonna be a big change.
And then
What else have you got?
Well, I was going to add to that. I mean, just with this progression in battery technology, that's going to be exciting to see what the Panasonic Tesla Gigafactory comes up with. As opposed to status quo. I'm sure there's going to be a lot of R&D in that.
It's of course they're going to make the 18650 batteries to build their car.
Sure.
A lot of the investors are like, well, what if a new technology comes along and displaces that? The factory is a big deal, but it's not cast in stone. They can take out machines and put in machines, and will be anyway for the life of the factory. There's always going to be a new technology coming.
That's true.
And there's always going to be a decision about the form factor that you put the chemistry into. That's going to be life at the Gigafactory.
Yeah.
There'll never be a day in the history of the Gigafactory that they don't have engineers working on the concept of removing machines from the building and putting machines in the building.
Sure.
To make batteries.
They'll be retooling. Yes.
Forever.
So my point being is the whole space is getting pretty exciting, and there's some breakthroughs really on the near horizon. So what else I have? BMW looks like they're going to come out with an electric SUV, the iSUV, to compete with Tesla's Model X. It's going to be in that same class.
Cool.
And it evidently.
What's the specs?
I have no specs just yet, other than.
How far will it go? How long does it take to recharge?
We have no claims on that. It's in fact it's all speculation. News of this iSUV comes via German sources who state that the vehicle will be built in the U.S. at BMW's Spartanburg factory, which is where all the current X's are made. Their current SUV line. But BMW has not denied this rumor, but has just kind of brushed it aside as speculation. So stay tuned on that. Here's something that applies to me. I ran out of juice in the truck last weekend, and so I had to.
Tell us about that.
Well, I had to get towed. I was on the other side of town and didn't quite. I guess I'm in the learning curve of.
And I wanted Bob in the learning curve,
rather than
I offered him the Toyota pickup truck that we got from Heber Springs.
I like that little thing.
And Jen wasn't driving it very much. She's mostly gone to the Smart. So I said, Bob, here, you can drive this around Cape and, kind of get used to the electric car thing.
Yeah. And so, with the OEMs like the Tesla or the Nissan, you got a gauge that it's going to says, hey, you're almost done. Well, I've got a JLD 404, and I, kind of knew what the number was, but then there's also the cliff that the batteries fall off of when you hit that number, and I fell off the cliff. So I found myself on the other side of town and unable to go, so I had to call AAA, and I got towed back here to the shop, at which point I recharged. Well, AAA just so happens in Colorado is offering a level 2 roadside charging. So it's obviously a truck with a big battery pack that it can do up to 30, level 2, 30 amps. It it says something about it also can provide 80 amps, but at any rate, it's about a 15-minute charge to give you 10 miles to get where you need to get, get to the next charging station. So that was something I wish that we had here in Cape.
Here in Cape, I've done it a number of times. You get a flatbed, it's $45.
Yeah, and I have AAA, so it was nothing.
Oh, really?
Yeah.
Well, that's cool. I need to get AAA then. Yeah. Each car is different, and it does take a little getting used to. Bob would plug in for a couple hours, but that old guy in Heber Springs put in a 200 amp hour cell, 48 cells.
Yes.
It was a pretty big pack. So it kind of takes overnight to charge it up. We've got a little, maybe 3 or maybe a 4 kilowatt charger back there. I don't even know.
It seems to do the job okay.
Yeah?
Well, I noticed the JLD, it looks like it's putting in 20 amps when it's running.
Well, that'll be 10 hours.
Okay. But still, right, exactly.
2 hours doesn't do you much.
Yeah.
But these are kind of variable between vehicles. You just kind of have to get used to a particular car.
Sure.
And my little VW thing's only got 60 amp hour batteries in it.
Okay.
You got 200s in there.
Yeah.
Of course, I've got 350 volts, and you got
160.
160.
Yeah.
So all these numbers are. It's just you have to get used to them. So he's kind of getting used to the idea, but had a interesting experience right off the bat.
Yeah.
and so there you go.
Can't take him anywhere.
But I didn't know that. I hadn't thought about that. Maybe we have to join AAA just to get cheap.
It's a good thing to have.
Sledding.
I think you can use mine. I have up to 100 miles. I guess I can only use it once or twice a year. For the 50 or 60 bucks, whatever it was. I think.
By golly.
Well, actually, so this traditional or standard AAA is a 5-mile tow, which is certainly suits our needs here. But for my drive out here, I upped it to 100 just in case I needed a longer trip or longer tow.
Actually, we're kind of shorter trips.
Yeah, yeah.
The last time I was towed, Damien was here, and we were towed.
Yeah. In fact, I had the same guy.
2.5 blocks.
I had the same tow truck driver. Right? Yeah, he mentioned.
They're familiar with the destination.
Yeah.
The Obama administration has issued new rules for heavy trucks. Now, it appears these are going to be phased in over a number of years. And the trucking industry does not appear to be too opposed to it, actually. And here's why. They're going to require, first they're saying that 5% of the total vehicles on U.S. roads are heavy trucks, but they account for 20% of the carbon emissions from transportation.
Right. Because they're on the road all day.
Man, I drove
day.
to Hot Springs. That I-40 was solid trucks. There was hardly any room for cars on the road. They want the trucks for a 68,000-pound truck, tractor, and trailer to get 10 miles per gallon, and they get 5 or 6 right now. They estimate this would add as much as $14,000 to the price of a new truck.
Okay.
But the savings in fuel, you're talking about cutting their fuel charges in half.
Right.
The way they drive them.
And that's their biggest expense, and that's
their biggest expense. It winds up being like, oh, don't beat me. It's some more regulation, except this one, we probably ought to be buying these trucks anyway. And for the first time, they're actually going to mandate some aerodynamics and stuff for the trailers. And so that's kind of interesting.
I noticed some of those on the I-40 coming out, just various little sail type, aerodynamic things in the tail of the trucks.
Now, these are whether or not you do them type things. It's not there's any new science need to be developed. Daimler has a super truck, they call it, that I may try to work in some video here, that gets 12 miles per gallon now. So it can be done. It's just a matter of doing it. And so they're looking at phasing that in between now and 2027. But the trucks would be a significant amount of savings. Yeah, they say 5 to 7 miles is the current average of what they get, and so I think this is kind of an interesting area that we'll see actually over the road. I mean, if I was going to do one right now, Toyota's got a nice little brand new diesel engine, like 160 horse.
Okay.
And put that with a generator, some kind of massive batteries, a couple Tesla drivetrains on the back end, and it solves a lot of problems. I'm kind of talking to a friend of mine's sons, who were truckers, about their 12-volt system. They battle that and generators and stuff because they have their living quarters are in the behind the seat.
Yeah, the sleeper.
Yeah, it's a sleeper, and they got a TV back there, microwave, and all that stuff. And so I could make life so much easier for these guys with lithium batteries. It's
sure
not even funny,
especially in that rugged package you got.
Sure. Mm-hmm. And you know, when we could do any kind of package they needed, but if you did that and just took a small diesel and had it generating at a fixed speed, like any hybrid. Mm-hmm. Of course, the batteries could make up the power for the acceleration, and it takes a massive amount of power to accelerate one of these trailers and trucks.
Oh, yeah.
Once they're going down the road, it's a much more limited amount to go down on a flat road. Of course, some more to climb a hill, some less to go down a hill, and so your diesel motor wouldn't have to meet the peak then. It'd just have to meet the average, and the batteries could buffer all that out. And it actually probably makes more sense for trucks than it does for cars. I wouldn't bother with a hybrid car, but a truck, you got a lot of room.
Yeah.
And it almost works.
Yeah.
And I think I could get them into 14, 15 miles per gallon, potentially.
Now, where on the list do we put that?
Yeah, we'll put it right behind the boat. Speaking of the boat, let's take a look at our new acquisition this week.
Yeah.
Actually, it's not that new. I've seen this boat
it's
before.
a deja vu.
Let's take a look. Okay, Bob, we have got our Aristocraft back.
It's a beauty. It's kind of unfortunate, but it's added to the list of projects that we have coming up.
Yeah, we don't really have a time slot for it now. What happened was, what happened was, we had a guy, Jeff Southern, who's actually quite knowledgeable about boats. In fact, he did electric outboard motors in the early 2000s. And he kind of put in the request that he do this build. And we gave it to him last September. He towed it to Kennesaw, Georgia, which ironically is about 30 miles from where the boat was built.
So
which
it's well
has some
traveled.
other advantages. If something comes up, he's right there with them.
Yeah.
And he was going to install the drivetrain and a UQM motor. And we were going to use some CAM80 batteries.
Yeah.
And this was going to be a hot little number. It has a Sea-Doo
Oh, careful.
thing on
Careful.
it.
Do you want to take it off?
Yeah.
Okay, let's grab that side. Because those are the hinges there in the back.
So we've got this big opening here where we can do this, but we've been back and forth. I wanted to know what you thought about where to put a motor.
Yeah, in fact, we had Lucian, our neighbor machinist, come by, and we were, well, I was feeling that I'd like to have the motor right here, above the
Fiberglass part?
above the fiberglass part, yeah, because bracing it and having the motor out here is a little too cantilevered, and you know. I think that's kind of the way you were almost going earlier. I remember whenever this thing first came on the scene was you were talking about some Harley belts and drive systems.
I thought a belted drive system with the motor above the input shaft to the Sea-Doo would be the way to do it.
Yeah.
Jeff eventually got to, and he's got a pretty good sense of these things. He got caught up with some sort of higher work requirement. He works in training with a distributor of these PLC electronics, and trains people in companies to use the product, which then they're supposed to buy. And they had some guys working that. He was not working very hard for a while, but apparently they lost a few people, and so he has had a heavy work schedule and apparently waning interest in Aristocraft electric boat projects.
The back burner went to no burner.
Or maybe he saw something bad about this one. I'm not sure. But
you know, it's going to be a challenge, let's just say.
He was leaning back away from the motor on top to one lying in the bottom and in line with the shaft, which is how the Sea-Doos are connected to their regular four-cylinder internal combustion engine.
Okay. But what we only have
so
is,
I don't have a religion about it.
nor do I.
I thought it would kind of look cool, to look like a big supercharger or something, electric motor on top, big plate, couple of big gears and a belt and so forth, whirring away and blowing this impeller to drive this jet pump, which is off of one of the bigger, badder kind of jet skis.
Yeah, yeah.
Apparently the top of the line Sea-Doo is kind of bad to the bone.
They haul.
You can't really hang on.
Yep.
I think we can slow it down a little bit with this heavier boat, but the idea is about a 35-mile-an-hour runabout.
Yep.
You know, that you can.
Which will feel pretty fast in
this.
this thing.
Huh?
That'll feel pretty fast in this little boat.
Yeah, down low to the water,
Yeah.
and in this smaller boat, it'll feel very fast.
Absolutely.
And, you know, for two people, kind of a speedster of the water. Take the wife and a couple bottles of wine and go tour around the lake in the evening. I'm not going to want to sail the Caribbean in this thing.
Sure.
It's more get a couple of bottles of vino down her. Maybe I'll get lucky. Huh? So that's
better make it
kind
free.
of the plan. It's a recurring theme at EVTV. But the mechanical concept of mating up an electric motor to the Sea-Doo shaft is really past my pay grade somewhat. So you're either going to have to work something out or we're going to have to call somebody in.
Yeah, we'll...
if any of our viewers are aspiring to get in the electric boat business, we could probably use some
guidance, for sure.
Adult supervision here.
You know, I'm not opposed to putting it in front either, but, you know, the diameter of the motor mating directly with the shaft is not really a reality.
Well, there's going to be a little incline.
There will be some U-joints of some sort.
Isn't there a little U-joint on there now?
You know, I'm not sure. It does flop around in here a little bit, so something is going on behind here. Don't know enough about it yet. You know, and what can we actually, you know, mount to on these spars in here? So,
well, that's the trick. Is it's pretty thin plywood there on the bottom. You actually have to
we're not mounting that. We got to hook to these solid spars to do anything.
That's why I want to do the over thing. We could make a plate that mounts to that fiberglass.
Right. Well, and
I don't mind drilling holes in the fiberglass. I don't want to drill any in the wooden hole.
New. Exactly. And, you know, we really, factory-wise, only have 2 mounting points of the existing, you know,
Sea-Doo, and that's what I want to build off of, is,
Right.
you know, make my plates and such from there.
So if we made kind of a L plate
Yeah,
and mounted the motor up here coming out, we've got a bearing in the motor,
yeah.
and then another bearing.
Like some sort of carrier for the shaft here. I mean, with this whole shaft would actually just get replaced with something custom, that we would have a carrier off of something. You know, maybe, I don't know what these are, even the weight of the motor, the back of the weight of the motor, maybe it gets braced up on this flat spot here, you know. Sorry, you guys can't really see exactly what we're talking about at the moment, but, you know, there are some engineering challenges for sure.
Okay, well, we'll stay after it. Like I say, my priority at the moment is get that Tesla done, and I want to get our really our first UQM, which is a very nice package, is that green thing.
Yep.
I got to tell you, it's hot here in Missouri, and I haven't really pulled out the Escalade in anger in a couple of months, because that little yellow thing, constant comments everywhere I go.
That's fun. I drove it once.
And it is fun to
It's a fun
drive.
little car for sure.
So unfortunate, we've got our boat back, nothing done on it, and lost nearly a year. That rolled away from here in August of last year, maybe September.
Well, thankfully, it's not as banged up as the one that came from Amsterdam.
Well, right, it's, and it's still a handsome
It's not
boat.
banged up at all, really.
We've got a lot of projects in ahead of it, but you know, it's on the list, and it's still a nice looking boat.
It's a beauty.
A Toyota.
Yes.
They still don't want to play electric. Well, they play electric, but they want it to be powered by hydrogen.
Yeah.
But they have the cutest commercial. Let's take a look at this little bit of video from Titusville. They're playing it all over YouTube.
Oh.
You've undoubtedly seen it.
It would happen in Titusville, Pennsylvania. The story begins with the arrival of Colonel Edwin Drake to inspect a strange spring that bubbled oil.
We're standing just feet away from the original production oil well, drilled by Colonel Edwin L. Drake. Basically, it was the very first time that man could get oil out of the ground in any kind of amount. This is Titusville's motto: welcome to the valley that changed the world.
Our tagline is, the birthplace of the oil industry. If you look at the first census, there were maybe 200 people. Then the oil boom hit, and this place exploded.
We had thousands of people pouring into the oil region, and they started punching holes in the ground everywhere, and I mean everywhere. Oil Creek is where oil was first found. That's why it's called Oil Creek. It was the lifeblood of the area.
We used it for the transportation, we used it for business. We wouldn't exist if we hadn't had that creek. I know, it's creek. Well,
vehicles, electrolysis, and several other things that we're going to be studying here in the near future. I'd like to introduce our special guest speaker today.
Hi, everybody. I'm Larry Moulthrop. I'm a chemical engineer. I graduated way back in the dark ages in 1978.
Titusville prides itself as being the beginning of the transportation revolution. We're now on the cusp of a new revolution in transportation based on hydrogen.
I see an opportunity to bring these ideas together, and how about if you help me go gather some water from Oil Creek, and I can convert that water using electrolysis to create hydrogen and power a fuel cell vehicle. We can bring that vehicle back here, and together we can tell the story of how we're powering the next phase in transportation. Will you guys help me?
Sure.
Yeah? You into it?
Yeah.
All right. As you can see today, hydrogen is everywhere.
Before we had drilled for oil here in Titusville, Native Americans would skim oil off the top of the water. I thought it was pretty cool that we're actually coming back to Oil Creek and we're just taking the water out.
With the water we collected, 150 gallons worth, that's enough to electrolyze and fill over a dozen Toyota Mirais. Water electrolysis allows you to take energy, renewable energy when it's available, channel it into the electrolyzer and break apart these water molecules. You now have potential energy in the form of gaseous hydrogen. So put that into a Mirai, combine it with oxygen from the atmosphere, and now you can power the vehicle. I want to see how excited they are to explain to the people in Titusville what their perspective is, how they view rich traditions established here in Titusville, and how they view this new innovation based on hydrogen.
It may sound like it's just a theory at this point, but if you follow me, I will show you the actual car, the water from Oil Creek outside.
A simple science experiment that we've been doing since middle school, and it's actually being used in cars and making them run.
Through innovation, mankind can seek things out and grow and change.
I never thought that my little town would be part of such a big thing, but now I'm actually driving the real car, and it feels awesome.
To bring it back here to Titusville, where we started the oil industry, it's a proud moment. It really is.
But if you haven't, there it is.
There we go.
School kids taking water and electrolyzing it to make hydrogen to drive on. It's just in Titusville, Pennsylvania, where the first oil wells were planted. All about hydrogen. I love hydrogen. The one area more fascinating than electric vehicles, actually, is the one I was involved with when I got interrupted with the electric car and the lithium batteries. And that is a photocatalytics. No, you have to have whiskey to be able to do all this stuff. Photocatalytics is where you expose various materials and water to sunlight and make hydrogen and oxygen directly without electrolysis per se. And the magic combination, of course, is the famous one, is titanium dioxide and platinum, first discovered by Shell in 1977, Shell Oil Company. And so I was playing with ways to make hydrogen in your garage, fill balloons, and burst them into flames.
Blow them up, huh?
Using ground-up catalytic converters, copper pipes,
oh, really?
Plexiglass, and milky solutions of titanium dioxide and water.
Maybe we should revisit that.
In the sun.
That sounds fun.
It actually is a lot of fun. And so that's, I love hydrogen. I just don't want it in a car.
Yeah, it's quite volatile.
Isn't
would be the word?
The
or
fuel cell isn't
flammable?
the problem. It's the tank.
Yeah. The pressure.
Hydrogen has even less energy per unit volume than a lithium-ion battery. And so you have to, in order to have enough hydrogen to go 100 miles, you're talking about
10,000 pounds or something? Or?
Yeah, 10,000 pounds of pressure.
Yeah. So you've got this.
That's a bomb.
Yes.
That's not a tank.
Right.
A pressure tank at 10,000 pounds ceases to be a container and becomes a bomb.
Let's blow that up.
Yeah, blow that up.
And blow up the city.
And then, of course, because it's somewhat dangerous, we would have tank inspections.
Yes.
And have the expense of replacing tanks that failed the tank inspection. And so that's actually my main problem with hydrogen. You have a secondary problem.
Infrastructure?
Yeah. You have to have a huge infrastructure.
Yeah.
That's 3 orders of magnitude.
Transportation
more
costs.
expensive and time-consuming to install than any electric infrastructure you can imagine.
That's already in place?
Well, even if you count Tesla superchargers as being required for all cars, it's not that big a deal.
Yeah.
Compared to putting 100,000 hydrogen filling ports in 100,000 gas stations. It's just almost unthinkable.
Give it up, Toyota. Please.
Give it up. Rich Morris in Stoughton, Wisconsin, and he is a Studebaker.
And he was here for the Tesla breakthrough.
And he is making Studebaker up in Stoughton, Wisconsin.
Studebaker.
And having kind of a, what do we call it, a steak fry of it.
Okay.
He's burning up equipment in Stoughton. Let's take a look.
Friday afternoon in Stoughton, Wisconsin, and I want to update you a little bit on the Electric Studebaker. Out on the Yahara River, which runs through Stoughton, doing what we like to do on Friday afternoon in Wisconsin, which is have a beer. Anyway, we've made a lot of progress on the truck. We have the bed tilting now, which is very convenient and very lovely. Mike Hendry did a great job on the calculations and put a 250-pound spring in for each side, and it just makes it like nothing to raise and lower the bed by hand. So that's really lovely. And we balanced the batteries, did that over the weekend, so now they're all set to go and strapped together. I did put the power to the chargers, and they didn't blow up smoke, so I'm very happy about that. They look ready to go. But today we did run into a little bit of trouble that due to my color blindness and due to the fact that the cables that shipped with the Coda/Volt battery chargers, I wired up the AC wrong. So had ground hot, flipped the breaker, but before it flipped the breaker, I guess it took out the CAN-DUI. So now I'm waiting for a new CAN-DUI to get that working right. Oops. Down the river here, but getting a little bit out of control. I am using an electric motor on the boat here, so I'm living the electric lifestyle. So anyway, as soon as we get our CAN-DUI, then I'll get it charging. Once we get it charged, then I can spin the wheels, which will be a very exciting time. Should happen next week, assuming we can get the parts, and we'll go from there. So I hope everybody's having a good summer, and here's a little bit of video to go along with it. Okay, so here we go.
Alright, this is field test number 1 on truck bed lifting. Oh!
Look at that. So how does it work?
How does it work?
Yeah, point out the...
Well, if you look on both sides,
oops, here,
we have gas springs mounted to the bottom of the truck bed and then down to the side of the frame.
Each spring lifts 250 pounds.
And Mike calculated what the angles and everything we needed to be to get this to be.
And the pivot?
So look.
Oh, the pivot is in the back with the. We use the back end of the truck bed. There's a mount for the bumper, and we use that as the hinge point in the back. And Mike's calculations figured out where these needed to be to get the truck bed to go up after it's about a third of the way.
Yep. You can do everything with less than 20 pounds.
Yep.
Okay, now go ahead and show it again.
So here we're pretty much comes down one-handed.
Beautiful. And so Dwayne and Greg and Mike implemented it. Here we're having the Studebaker lunch, and these are all people who are involved. You want to identify yourselves for posterity?
Nate.
What?
Nate.
Oh.
Mike Naughton. Brian Sanderson. Dwayne Kaufman. Mike Andrew. Bob Schofield. Ben Pepperaki. Peter.
Greg Fuentes.
And right now Greg's trying to figure out where to mount the accelerator. It's a combined session.
Yeah, let me put my lunch down.
And you keep thinking that it can go out here.
I'm going to put it right here. Somewhere in there, and then the linkage arm is down there.
And we'll see if that works.
Yep. And if the ID guys can't get here to screw the parts on, I'm going to work around them.
And the battery boxes are finished and balanced. What else? Oh, I got video of the back already.
Yeah.
And everybody's just waiting for it to spin its wheels.
As our world grows, it's necessary to invest in sustainable transportation to reduce our impact on the planet and ultimately create economic efficiencies wherever possible. Electric vehicles are becoming the leaders of this efficient, sustainable movement. In electric vehicles, the driver experience is just as important as the batteries that power it. EVs display different information than conventional vehicles, such as the amount of energy stored, expected mileage on a current charge, and distance until empty. Monitoring vehicle efficiency and energy consumption are more critical than ever because of driving range limitations experienced in EVs that are different than your conventional vehicles. This presents new challenges to structure and simplify new driver information for operating EVs. Andromeda Interface's EVIC was designed to collect, interpret, and consolidate data onto one vehicle dashboard to provide a reliable and configurable device to monitor the operation and safety of your electric vehicle. From monitoring your motor controllers to your battery management systems, EVIC is a human-machine interface that seamlessly interprets all the complex data coming from these devices. EVIC presents the driver information in one simple display unit, and we are continuing to build our portfolio of certified interfaces from other EV suppliers. Please review our list of supported EV components on our website. Andromeda Interfaces is striving to enable human-machine technology that helps improve the safety and efficiency of electric vehicles. By doing this in a cost-effective way, we are helping to accelerate the growth of sustainable transportation.
I can say nothing. Here's why. Rich come down to pick up all this equipment, and I was demonstrating these OEM things, like 2 volt chargers and a volt DC. 2 Lear chargers and a DC to DC converter, and I had them the polarity reversed on the pack.
Gets the best of us, right?
Blew them sky high. I mean, a column of smoke. This week, Bob, in hooking up the charger, explained to me how he knew better, and here was the black stripe, and here was the orange stripe, and here was how it had to be. And I said, Bob,
no, please, that was a suggestion, or yes, colors.
No, you were pretty clear on it.
Well, I did actually have it wired up that way.
I did not say bullshit.
Yeah,
I said,
Yeah.
I've been burned on this. Let's go check this. And we went and looked. I didn't say it was wrong. I didn't say it was right.
Yeah, that's true.
I said, let's check it because I'm not sure. Before you apply power.
Yeah, no, and that's why I did not apply power. But I did actually have it wired up wrong, so I do take the heat for that.
Well, it would have blown. Don't ask me how I know. Column of smoke. You have to have a polarity right on this.
That would have been a huge.
And the problem is the connectors we get are kind of. I mean, it's very difficult to buy these connectors, so we get them off the cars, and it might be a connector that fits something else, but it fits that connector.
Yeah. Okay. Right.
But the wiring isn't right, so I've got a little diagram in the book. The right side is positive, and the left side is negative as you face the connector on the charger.
Right.
And so then we looked, and sure enough, the right side, which is positive, is the one that had the black stripe.
The black stripe, yeah. So colors will kill you. Do not rely on colors.
Yeah, that's what I told him. I said,
it out.
Color codes will kill you.
Yeah.
Because not
that's
because
a tough one
they're
to get
wrong,
over.
But because somebody hooked it up, not per the color code.
And this is, because when I was a kid growing up in a shop, my dad said black is always negative, red is always positive.
And if everybody follows that,
get that out of your head.
But don't count on it.
Yeah.
Don't bet your life on it.
No, we don't want to do that.
Or your charger.
And we can,
And so there you go. So yeah, I had already done this right in front of Rich Morris. Rich needs some, apparently, he doesn't think the chargers blew up, but the control boards went crazy. And so we will get those out Monday morning and overnight them to you, Rich, and should get him charging. He's just charging the battery pack away from driving that truck.
Yeah, all right. I can't wait to see it.
Yeah, I think so too. Damian McGuire in Wexford County Court and was one of our 5 hack team guys that bought cars the same week.
Yeah.
And he bought him a Nissan Leaf, a little bit more expensively over there, perhaps. But he wanted one, and he's going to cannibalize it for Der Panzer. But first, he wants to see how the Leaf does Chatamo with a little can-do-y capture of that data. Let's see Damien wrestle with it.
Hello sports fans, and welcome to the first in our Nissan Leaf hacking series. Some of you may know I've recently purchased a Nissan Leaf. It's a 2011 model, and we're going to be doing some hacking and some parts usage for our Panzer project. So first thing we want to do is we want to be able to capture some CHAdeMO CAN data, see exactly how the OEM guys do it. So in order to do that, we need to tap into the CHAdeMO CAN bus. So this is the procedure that I'm kind of following here, and big thanks to Dave Davies in the UK for some of the captures that he's done, and also for some of the tips of what I'm about to do now. So first things first, we get rid of some plastic clips here, and we get shut of this piece of plastic trim. Now once we get that out of the way, we've got a much clearer view of our fast charging port back here, and the signal lines come in on a nice cable here, and there's a multi-pin plug that I just released from the body with a few clips, and we get this nice male multi-pin plug here. That's the body clip. I just pinched that with long nose pliers. Thank you very much, Harbour Freight. And we now have some male pins here, which are connected to the pins on our CHAdeMO port. So the next thing we need to do is we got to get our CAN high and our CAN low identified on this harness so we can tap into them. Alright, so I just grabbed a multimeter and put it on continuity test, and we know from our previous CHAdeMO experiences that the can lines are the two guys here. So I'm going to stick this into one of them and see if we can identify it on our multi-pin plug here. There we go. There's one of our can lines, and that is a blue wire. So yeah, that's blue wire here on the plug. Is that a plain blue wire? It looks like it. So that's one of our can lines. Not sure which one, but I'll look up a diagram in a minute. Let's go to the second one. There it is, right beside it. So it looks like the blue and the yellow. So I'm going to get you guys a close look at this connection here, and we'll get a diagram so you'll be able to see which wire is which. Alright, so I'm trying to get you guys in as close as I can to this plug here. And just looking at my diagram here, I've got the multimeter on, and bearing in mind of course that this is the plug I'm looking at, so this would be pin 9 of our CHAdeMO. So pin 9, which is can low. Can low is, where is can low? Ooh! Can low is when I kicked the tripod. Okay, so can low I think was the blue wire, was it? Or was it the yellow wire? Sorry. Yellow wire. So in this connector, can low is our yellow wire. Yeah. Can low is yellow. And let me just change it over and just double check my diagram. So pin 8 is this one here. Pin 8 is can high. So let's move over to that one. Pin 8 is can high. And I think that's the blue wire. Yeah, it's not connecting to anything else, which it shouldn't. Just to be sure. Yeah. So the blue and the yellow are your CAN bus, folks. So pin 8. Pin 8 is can high, and it's blue. Okay. Now we just got to tap into the damn thing and reconnect that plug, and we should have some CAN bus. Tweet tweet. So another good way for us to know that we're actually on the CAN bus here is that my blue and my yellow wires are actually twisted together. So that means we got a CAN bus. Of course it doesn't always mean that, but it's a pretty good sign. I've also got some wire made up here, which I've also twisted. Got a black and a purple. Just used the cordless drill trick just to twist these guys up. So it is a 500k bus. So the next thing that we need to do is to tap in here. And what I'm going to do for that, I think, you know what I'm going to do before I do any of that? I'm going to close this thing because it's in my way. That's a lot better. Alright, now, so my blue and my yellow. So, I've got my little battery powered soldering iron here, so I'm going to pretty much just break in here and solder on my wires, tape it up, and we should be all set. I want to do as little damage to these wires as I can, because obviously I want to reuse this socket in the Panzer. So let's see what we can do here. I don't know if you guys are going to be able to see this, but I'll do my best for you. Kind of evening time, so the light isn't fantastic. Probably for filming. I'm just going to nick off a bit of that insulation there. That's really all I want to do. I do have a nice sharp snips, which helps. There we go. I just want to get rid of some of that insulation from that wire. I'm sure there's other ways we could do it, but I do have some of those telecoms style, they're kind of a bed of nails test pin type of thing that we could use, but I want this to be semi-permanent because I want to be able to log various charging points. So then we got to get a way then to get a USB cable from here into the firewall. So that's going to be fun games, I'm sure. I don't think Nissan exactly had that in mind when they were putting this tin can together. So now, and I've never used that battery powered soldering iron either. Picked it up in Dublin at the weekend, so I did see a review online for a very similar one, so here's hoping it's actually fairly decent. A little bit more of that insulation away. Probably get a finer snips for this. Yay! There we go. Yeah, I'm not doing too badly for a Muppet. Yeah, this car kind of came at the right price at the right time, so I just basically grabbed it. And I'm going to have a lot of fun. There we go, got that insulation stripped back off that yellow wire, which is our can low, and we're going to connect our black tap wire to that. I'm just going to twist it around it, like so. And I'm probably going to keep this mod on here even when I put it in the Panzer, because we're going to want to be able to log the CAN bus as well as actually sending it to our JLD 505. So there's 3 AA batteries in this little thing. You got to hold the button for 30 seconds. And apparently you're good to go. So let's see what happens. Got some smoke. That's a good sign. Oh yeah, that's melting solder. Nice. Let's see if it's got enough power just to do a simple little wire splice. Something happening here. What it is not exactly clear. Uh-oh. I think my oh dear. My battery powered soldering iron is a piece of crap. It doesn't appear to be very good at what I'm trying to do here, guys. I guess the one that I spotted the review of must have been a different one. Yeah, this is making a real mess. Just doesn't. It seems to be able to melt solder on the tip, alright, but when I actually touch it up against the wire to try to transfer some heat into it so I can solder the wire. Yeah, it's just basically coming up short on me. It's just cooling off. So there you go. Well, okay then. Don't buy this. Don't buy this. Okay. Better go get the real one. Okay, so we've got a real soldering iron this time, but I might have been a little bit harsh on my little battery powered friend, because I think that was that lead free nonsense. So I'm going to give it another shot, but I've got my trusty mains back up here just in case it doesn't quite cut the mustard. So this is our blue wire on the leaf, which is can high. We're connecting that to purple here on our tap lead. Yeah. Let's see what happens. It still seems to go cold when I'm trying to solder this. It just doesn't have the welly. So okay, back to the original statement. Don't buy that thing. Sorry, that thing, but you're just not up to the task. There we go. Job done. Oops. So now we got to tape up that wire there. Make sure we've none of those nasty shorts going on. Then we can put it all back into this little bit of trunking here, and would be funny to bring this in for a service though. Haven't had a problem with the fast charging port. I want it to do, and it wants to do what it wants to do. Oh dear, oh no, straighten it out. I remember doing car loom wire when I was younger. It's kind of an art. Not one that I ever mastered, I'm afraid. Alright, there we go, look at that. Practically factory. So let's get that back in there. That in there. I'm going to retape this part of the loom here. This was going to retape the conduit and retape this bit here. Don't have to go too crazy, but just enough to keep out any environmentals. There we go. Now, let's see if we can reconnect it to the vehicle harness. I've got some insulation upstairs, I can run around that if I want to, but it's not like there's an exhaust manifold in here or a set of HT leads that I need to be worrying about. So, let's see if I can see that Japanese cars are quite well packed. Let's see if I can get that connection in there. Yay! It's in. And if I re-snap it onto the body here, we should be just about all set. All the fun of the fair, isn't it? I mean, all this hacking stuff, it's not about, you know, it's not all about the fun and the big headlines, is it? It's more about the mundane stuff as usual. Here we go. There we are. Alrighty. That is back in. We are tapped in and ready to rock and roll. As I said in Die Hard 2, all systems tapped, Colonel. So, let's get this guy hooked in here. And I'm going to get a bit of insulation around that. There's a bit of body work there. It'd start chafing on that pretty much straight away. So I'm going to do that, but we got our CHAdeMO CAN bus, sports fans. Stay with us. Okay, so we got our CANDUI set up. We've got a 9-pin D connector. Got my power and my ground on a separate wire. And I've brought my CAN bus in here on the CAN high and the CAN low terminals. So what I'm going to do now is I'll disconnect that D connector. I'm going to just tape this up just to keep it all nice and neat. The advantage of using the D connector here is that I can very easily swap the card between the two cars. So we can log with the leaf, just come along, unplug this guy, unplug the USB. I've got it velcroed in on the land yacht, and I'll velcro it in here too, and we'll pretty much be able to just swap the board between the yacht and the leaf. Yeah, we should be all set really. pretty straightforward then, and we'll go visit a charge station. So all I got left to do is just going to put a fuse on the battery there, so I can get my power and ground, and we're all set, guys. So see that on there. So just before I try to power it up, what I'm going to do is I'm going to just double verify with a multimeter that I have these pins right, so that my black is my ground, and my red is my 12 volts. So very easy to do that on the CanDui, because we already have the terminal block there. For also gives us the ability to use CAN 1 and also 12 volts on ground. Just going to grab my 12 volt line here on my cable. Just go here 12 volts. And indeed that is 12 volts. And ground here. There we go. That's us, guys. So alright, I'm going to get a fuse rigged up, and we'll put some 12 volts to this thing. But we'll be back then when we're when we're actually getting it installed into the car and getting a USB cable rigged up to the thing. So stay with us, folks. We'll have more leaf can hacking and CHAdeMO hacking to come.
You know how many battery powered soldering irons I've owned?
No.
Half a dozen.
Okay.
You know how many of them have worked?
0?
Yep.
Okay.
Right about
Rough.
0 plus or minus.
Give or take.
All of them. 0.
Yeah.
Sounds like a great idea. I've never gotten one to work. Maybe that's what we ought to do, is invent a lithium battery powered soldering iron.
There we go.
And that actually heats up.
In the day you want to use it.
He's in the wind. It would melt the solder, but as soon as you hit the wire, the heat wicked off, and that little thing just couldn't do it. Anyway, Damien is, fighting hard just to get wired up to the leaf so he can capture CAN data from the fast charge, which again, Ireland is looking at 100 fast charging stations in an area half the size of the state of Missouri.
Right. One in every household.
And there you go. We continue with the Tesla drive unit test set, test bed, test bench. Well, actually, the whole east end of the shop now.
Yeah.
Fried chicken boxes and iced tea glasses everywhere.
A couple of late nights, and
we've been fighting it
some
unnecessarily hard and with the meager to show for it, but some progress. Let's take a look. When last we spoke from the Tesla drive unit test bench, we were going to install the JLD 505. This is kind of Paulo's invention for a battery management system. We're working on a new version of it, but I thought we would put it in play here to do a very specific task. As we know in the past, a lot of our CAN decode is to observe something in the real world and try to associate it with CAN messages. Timing can be a problem when you're doing several hundred CAN messages per second.
Right.
How do you get in the right time zone with what you saw on the meter? We've got a real problem this time, because our frame rate's about 1,500 frames a second.
It's booking along.
It's squirting a lot of data.
Yeah.
And so we need a little different technique if we can come up with it. And what we're trying to do is to wire up some sensors and then have them produce CAN messages with their data in them,
right,
in a known format that we know.
So we have check marks or...
And interject that in the stream. And so it'll appear in the data stream in a time analogous to the readings from the inverter.
Right.
Obviously, the ones we're playing from the car are just to make it go. They're not going to change based on any of these sensors. But we are going to be interested in the inverter stuff. I've written a program where we can strip out all of the inverter signals from the car stream and send it to the inverter. But we can use that same program to then strip out all of the car signals, leaving us with the inverter signals and the ones from the JLD 505.
Right.
And so hopefully we would then have sensor data interspersed with our inverter data and maybe make some sense of that.
Right, so they happen at the same time.
So Bob was going to install the JLD 505. How'd it go?
It went well. It went well.
What did you give me here?
Well, we've got pack voltage, we've got current, we've got 3 temperature sensors in various places on the coolant tank, on the inverter, on the motor, and an inductive pickup for the RPM sensor.
Okay. So we're hooked up to the shunt for current.
Correct.
And you got us to lead to the pack positive.
That's right.
So we get voltage.
We've got voltage and current.
Okay. And then we have 3 Dallas one-wire maximum temperature sensors. Therein lies the tail.
Yes.
And what he set me up over here is that inductive pickup that I showed you before on a nice little stand. Can you point that out to him, Mom?
I don't know if you can see that from there, from that angle, but it's a little aluminum Z bracket.
Yeah, so it's right off of our CV joint piece there. And how many magnets did you put on there?
We've got 6 magnets on there.
Little bitty round magnets.
Yeah.
That as that rotates, it'll cause a pulse.
That thankfully have not flown off at max RPM.
Oddly, at up to 16,000 RPM,
they still hold.
They don't fly off like bullets and take anybody out. It's an amazing.
We're still intact.
And so,
still,
that's what we've got going there. I've written an entirely new program, really, to try to bring all this together and calculate the speed of the shaft, which we're going to call gearbox RPM.
Right.
And then that gearbox is 9.73. So if we multiply that by 9.73, we'll have motor RPM.
Yep.
And you looked up the tires.
Correct.
On the
21-inch wheels and
21-inch wheels for the Model
Were they
S.
245, 35, 21s? I can't remember the exact. It was like 87 inches and some change.
81.187 inches.
81.187. Okay.
And so from that we can derive a miles per hour.
Right.
Now we haven't had that luxury in the past. For the transmission, it's kind of hard to tell. But with a 1-speed gearbox, you can tell. And I bet they report it.
Ah, yes.
I suspect that the car, or perhaps the inverter, modulates the amount of regenerative braking based on a speed.
Right, so it doesn't go full regen at 100 miles an hour.
Exactly.
Right.
And so we're going to test for that and check for that. A couple of surprises. Recall we followed Michael Elias's teardown of his Mercedes-Benz version of the Tesla drive unit. And he pretty much told us that the coolant goes through the inverter.
Yep.
We can do temperatures, and we have 3 sensors, one on our coolant tank, one on the motor, and one on the inverter. And I can tell you that they're not connected. The motor and the coolant tank track pretty well. The inverter is quite behind it and doesn't really follow it.
Right.
It does increase in temperature, but obviously not nearly at the rate of the motor. But if the coolant was going through the inverter, it would actually heat the inverter up to the same temperature.
Right, right. So thankfully the inverter is actually cooler than everything else.
I do not believe the inverter is in that coolant loop, guys. I think it's air cooled, and that those 3 channels he saw were simply the 3 phase bars.
Yeah.
And it remains remarkably cool for what we weren't doing a great deal of current, but
we're not
still
really putting much of a
36,
load.
37 degrees centigrade. The motor would get to 47 or 48. Again, we have no load here.
Right.
And the gearbox would kind of match that with the handheld.
Yeah.
It would get warm. But the inverter was not following the other two. And we could pretty much track the coolant temperature to the motor temperature within a degree.
Yeah, they were.
And as they went up and
pretty in
down, they
step.
went up and down. The inverter, simply, it would still be going up when these two are going down and vice versa.
Mm-hmm.
And so my conclusion is that we are not at all connected in that coolant loop, and the inverter is not liquid cooled. As you can see on the thing, we have our Elon Musk bobblehead vibration detector.
And he's riding pretty smooth.
And he's
cruising along.
Just barely nods his head at 16,000 RPM.
Oh yeah, it's actually like more in the deceleration when you get into the last
Into
2,000.
the regen type thing.
Yeah, then he gets a little hoppy, but.
Now here's what we've done with our input. We took a very brief capture from the car, where all we did was got in the car, put our foot on the brake, put it into drive, took our foot off the brake, and stopped the capture.
Right.
And that's all it was. Now, through the miracle of time-lapse photography, I took the last little bit of that and added it on about 10 times.
Right, to grow the
and then
file.
went from there and copied that, to where we now have a file that's basically putting it into drive, takes a couple seconds.
Mm-hmm.
And then what do you think about 15, 20 seconds of just being in drive? And at that point, he can control the motor all the way up to 16,000 RPM.
So I think I
and
saw
down while having full regen.
Yes.
And so we can play with the regen, and we can tell that it's not regenning as much at 100 miles an hour as it does at 30.
Right. No, it actually it's when you get down into the lowers that you really notice the regen. You know,
so
from the high speeds it eases into it.
So what we've done is do a program that about every 20 milliseconds sends a set of CAN messages carrying this data. I've got this machine with a CAN Dewey kind of logging the data off the bus. Bob's got a Windows machine where we're injecting
that's the file we're loading,
the card data.
Yeah, to make it
and
play.
I've got this machine over here behind me, which is displaying the sensor data that's being encoded into the device. So we're going to go through this a little bit to give you an idea of what's going on, and I'm going to do a screen capture on this side where we have the sensor data. Unfortunately, there is a bad conflict in the libraries for the Dallas one-wire temperature sensor.
Yep.
And apparently, the CAN library, when we're capturing temperatures, as soon as we start transmitting the car data onto the bus, as long as the inverter data is going onto the bus, about 500 frames per second, it seems to be okay.
Mm-hmm.
But when we add the car data, and by the way, I don't have any code in here to receive CAN data. So I'm not sure how this works.
A little stumped.
The transceiver does have a hardware interrupt line that is connected to one of our hardware interrupts on the board. But we're not configured to receive it all. But somehow when we get to 1,500 frames per second, it locks up this program if I'm using any of the temperature stuff. So we still have a kind of a heroic bug in there. But right now I can show you the RPM and voltage and current pretty well. And we'll go through this. And Bob, what I want to do is turn the inverter on load up your file and send it, and then get, now hold on.
Are you logging?
Yeah, I'm logging over here. Let me turn on our screen capture here. And I am recording here.
Okay.
And so let's send the file. And now we're transmitting
about there.
over here. And right there, we go into Drive. Can you make it spin? And I'm seeing, we go to 410 and up to 1600.
There's the regen happening.
15,610. There's the regen. Let's take it all the way to the top. Give me what you got. Let's see how fast it'll go. And I reached 15,776, which looks like 134 miles per hour, and a gearbox RPM of 1,604. Now, we've had this at 16,000 before.
16,245 was the highest I saw.
Was that after the file quit sending?
I think so. Let's find out.
Let's spin it up. There's 16,337.
337.
And 139 mile an hour. And we can see we have 386 volts here, 0.78. Right now, we got up to 200 amps. Goose it and see how many amps we can get on this thing. Well, I'm not really seeing any. 8 amps.
Yeah, I've got 8.6 on the JLD.
And so you can see it gradually working down in speed. Now the other thing is the file has quit running. We don't have any regen. No, leave it on. We don't really have any regen here.
Right.
So there's nothing to slow it down on the load.
Right.
But we do have a differential gearbox. And you would think it would slow down a little bit.
Notice Elon.
The spin down, and there's Elon's head not shaking.
Just cruising along.
We're at 100 mile an hour here.
Yeah.
And still spinning down. And so here's the issue. 16,000 RPM is a lot of RPM. 1,600 out of drive shaft on a gearbox.
That's a lot of RPM.
Is a lot of RPM.
Yeah.
The inverter isn't even liquid cooled. And we're hitting 37, 38 degrees centigrade.
Yep.
The motor is at 47 or 48. We do have our cooling on now, but our fan hasn't even come on. We're vibration free across the entire range from 16,000 down to nothing. And so what I have to say about that is I've never seen anything like this.
It's a great package.
It's a great package.
I just can't wait till we can build something with it.
I've been on the F-15 Strike Eagle program, the F-18 Hornet, the AV-8B Harrier, RF-4C, Phantom, and the MX missile program and the Venus radar mapper. This is as good a piece of equipment as I've ever been in the room with.
It's a piece of
art. As best
art.
I can tell.
Yes.
It's a piece of art.
Yeah.
It's runs very cool, vibration free, at extremely high RPMs. I mean, this is turbine speeds almost. And this thing isn't missing a trick. It weighs
298?
298 pounds.
Yep.
And develops over 310 kilowatts of power. I'm getting pretty excited about the Tesla drivetrain. It's when you finish sending the file, then the thing goes into a kind of a limp mode. Now, when this stops, we will not be able to go again.
Right.
And that corresponds to the report of the serial number thing. But as long as we're sending the data, we can do anything we want.
Yeah, well, as long as it's even still running, I can still.
Right.
You
But
know.
once it comes to a stop,
It's over.
It's over.
Yeah.
But that's not the case while the file is sending.
Right.
That
and as
data.
much file as we keep giving it, it'll still be.
As much, and it's not very much data. I just took a little snippet off the end and kept adding it on
it takes
to the end
20,
until it
30
was
seconds to play
52,000
through it.
frames.
Yeah.
And that was after it was in drive. And so we'll be able to narrow that down pretty quickly, which bytes are actually necessary. And so this is going to be a controllable drivetrain one way or another, however we work out the packets.
Yeah.
But it's really a marvelous piece of engineering along the way is what we're learning.
Yeah. I'm
there
so
isn't
excited to be a part of
anything
it.
like this in a car.
Yeah.
I am too.
Yeah. You know, it just, last night, you know, we kind of thought we had some really good successes and, you know, and which we did really, but I was just on cloud nine.
Yeah. I'm suffering software hells over conflicting library interrupts in the Arduino Uno space. And I don't really want to be in Uno anyway. I want to be in Dewey. Polo's purportedly going to get us into Arduino Zero Pro, which is a 32-bit, 48 megahertz ARM core chip like the Dewey. And so then we'll have all our
84 megahertz.
48 megahertz.
Oh, okay.
Instead of the Arduino Dewey is 84. So it's a little bit smaller than a Dewey.
Okay.
But it's not like the Arduino Uno, which just simply doesn't have the chops to do what we're trying to do. Yeah. And but we're suffering some kind of a bizarre interrupt conflict. I think between the CAN library, and there's about 3 libraries. You have to have alt serial, DB2084B, and Dallas one wire to do temperatures. And the temperature calculation takes a little bit of time. And so whenever I call that function, the whole machine locks up.
Yeah.
If we're getting 1,500 frames per second. And so I still have to work that out. Get Colin to help me.
Yes, please, come Colin.
That's where I go when I get in trouble.
Yeah.
So that's kind of what's going on, but we continue to work on the bench. And now we can capture on this machine the whole data stream. And that is the stuff we're putting in, the stuff the inverter is putting out, and the stuff that our JLD 505 is injecting. Yep. And then strip out the car data and just examine the inverter data and the sensor data that we have, ultimately with temperature, RPM, voltage and current, and the derivatives thereof.
Right.
That we can calculate, like speed. We can confirm the specification for the Tesla Model S that it is speed limited to 140 miles an hour. The highest we've seen is about 138 and about maybe 16,300 RPM.
Yep.
And I'm fairly confident that is a software limitation in the inverter.
Yeah.
And
how much faster do we need anyway?
Well, exactly. No, I'm not trying. I'm simply confirming
we're not ready to go mock.
A spec thing about the Tesla. I also learned this week the entire body of the Tesla is 98% aluminum and weighs 431 pounds.
Holy mackerel! I didn't realize. I knew it was all aluminum. I didn't know the weight, but yeah,
it's pretty light.
Yeah.
Here's a drivetrain at 298. We typically get inside of that, not much, but with a third of the power.
Yeah.
And this includes the gearbox.
Exactly.
And so it's really an amazing piece of engineering art. The Tesla is just one of the best cars ever built. And
Period.
You know, I keep looking for the shortcut, as it was kind of a rapid development thing. But this looks, if anything, mature. If they're having problems with shimming or drivetrains going out, I can't find out why that would be.
No. You know, there's noises that you guys may even be picking up on, but I think it's just the
yeah,
CV,
there's a regen shutter, but I think if you put any load on that shaft,
yeah,
it's
right.
gone.
If you've got the inertia, it's just going to click just from the initial lash.
Right.
And I think the other noise we may hear is just the CV joints hanging out on the end without anything attached to them.
We've got our battery pack and our charger working, and so we can go back and forth. We did lose one of our 72 amp hour cells.
Yep.
That was kind of weird. I still don't know exactly what happened.
It was probably something to do with me.
Probably. It was like 4 random cells we threw together. We never balanced them. That's the first thing.
Ah.
And one of them was probably fully charged, and the other 3 were as shipped. And then we overcharged it with the charger that way. Not too sure how that happened, since the charger is supposed to be set at 13.5 volts. But in any event, that's the latest report from the Tesla Drive unit bench. I did get a new Dell laptop and forwarded that directly to Brian Gallagher, and he's going to basically install his tool chain for the EVIC, and I'll have to learn C# and be able to work on that a little bit. We're going to continue with this. This is sort of some tool building. Again, we're still working on SavvyCAN, and now this little program for the JLD 505. This is not a product or anything. This is just so we can monitor this test bench and insert this data.
Right. So
once we do that, I can make up little packets. Okay, guys, here's a drive under these conditions. We're in park, we put it in drive, we go up to
compare to
140
these
miles an
JLDs.
hour down to we're back down to 0, and here it is. And it'll be all the data from the inverter without the data from the car, but with the JLD data in real time, right next to the package.
I kind of liken that as to page breaks or paragraphing it.
Exactly.
Yeah.
And so we'll make up little work packs, and the hack team can kind of pick one out and go work on it.
Gang up on it.
See what they come up with, and then we'll compare notes by email. But I have to feed them something that is not nonsense, garbage in, garbage out, you know.
Exactly.
And so we've got to prepare a way to have a rational work file where they'll have a shot at success. And that's what we're working on at the moment. We haven't started turning off any bytes, trimming down any files, or really trying to get the motor to do anything other than some basic observations that when you hit the end of the file, then it kind of spins free.
Yeah.
But we can still run
As you can see, it's still kind of in a creep
look
mode.
This thing takes 15 minutes to spin down from 16,000 RPM.
Yeah.
That's a piece of precision machinery.
Yeah.
And I'm beyond impressed. I'm actually quite excited about the Tesla drivetrain. I'm starting. I'm starting to see how the car drives so good, and we want it to do more of that.
Yeah.
Stay with us. What do you think about that, Kemosabe?
Well, you know, I think we're making progress. We've, certainly hit some snags, but
we've spent a month sneaking up on this thing instead of diving in and putting the meter to it and starting to thrash with CAN. I thought this might get a little bit into a battle, and part of it's the frame rate.
Yeah,
they're just putting out a lot.
They are spitting data,
and so the other part is I thought it'd be kind of like, why divorces are so expensive.
I know this one, but I can't come up with it.
Because they're worth it.
Oh, yeah, exactly.
And I kind of had from the beginning that if we could actually master that Tesla drive unit, it might be worthwhile. After this week's work, which is really the first time we've gotten it up in the 15,000, 16,000 RPM range, done a spin down test, we still haven't put it under load, but I am thoroughly not impressed. I'm excited about this little piece of engineering marvel.
It's a really cool thing to be a part of. I could say that.
It is.
You know,
I'm
it just
kinda
is
into it.
It's just
so we're kind of sneaking up in a kind of an ongoing tool building phase, working with Savvy Can improvements, and now this week, Bob and I have just been beating our heads against a little multiprocessor that doesn't want to do this much work, but trying to get temperatures and RPM and voltage and current injected into the data stream so we can more easily look at it. And in my mind, with kind of the success of the hack team, make it easier for somebody that's not in front of the bench seeing this to see where events happened.
Exactly. Right.
You know,
Just
like
like a
when we
paragraph,
say we accelerated it in 7 seconds, they can see the voltage go down and the current go up.
Well, they can even see the RPMs. And the
RPMs bump on the data that we're putting in that we know. And so, and that'll be in the stream more or less about where.
About the timestamp-ish.
Right.
Yeah.
And so instead of whacking around with timestamps trying to get that right, we'll just put packets we know
The
about
event. We'll put,
in among the ones we don't.
A known event.
And then it'll be a known event. And I think that some effort in that tool building phase would be productive. Bobby had some stuff to talk about last week that just didn't make the cut at 2 hours and 4 minutes.
What was that?
About EVCon.
Oh, well, yeah, you know, it didn't make the cut. That's right, huh? So, guys, EVCon.
Some stuff just doesn't make the cut, man.
EVCon is on. Keep it in the show this time. It's we're set for September 29th through October 4th. I've been making contacts with you know, basically I've never done something like this. I'm trying to redo it, and you know, thankfully you know, Brian had left a lot of notes, and you know, he was really good at this. So I'm trying to basically duplicate what he did with the contacts that he left behind, and so we're getting that dialed in and lined up. You know, we've got hotels for you. We've got the arena, the Brace Arena. The caterers are, you know, queued up there, you know, so we're just slowly getting this ready to go. We need to get the website situated so that people can register, and we're, you know, it's coming. So please be ready, book your tickets, come out September 29th to October 4th. We're going to have a great time.
Okay. We've had, I've been approached by Steve West of New Zealand. I recall we did a spot with him and Nick Smith, and he's putting down a fast charge network in New Zealand, and he would like to come speak.
Oh, great!
And we would like to have him, and so we're going to have that. Tom Branco will be back. He's done a very popular series on brushes, less apropos perhaps to the direction we're going, but he has a new product and a whole new theme about grounding motor shafts to prevent rapid bearing wear from induced currents in the shafts. And he has a grounding concept for that. Damian McGuire will be here to demonstrate his new 750 volt 300 amp hour soldering tool that's entirely portable. You can put it in a shirt pocket, and we'll go out and you can solder on your leaf with that. But no, he's going to be our keynote speaker. He's promised.
Okay, good.
And of course, I would say with the ongoing development of the hack team, that there'll be quite a bit of EVCON is really going to be hack teamers.
Sure.
Meeting and laying out plans.
Right.
For the future.
Last year, I know we did a smart build, so we don't have anything per se in that arena. But you know, I think hopefully we have a lot to talk about.
Come up with one?
Well, I just hope. Hey, we got a boat, guys.
Maybe we ought to do a boat.
We've got. Well, sure, the Tesla will be. Coming along, you know, we're probably not ready to go into a car yet.
Now it's a matter, you got to have all this stuff lined up ahead of time.
Yeah.
So you need a set of rails and some sort of an adapter scheme and so forth. But that DOCA could be a project. And I mean, it's all pretty accessible.
Yeah.
And big and easy to work on and stuff. Throw me a Siemens in the back of that DOCA. And that would work pretty good.
What do you think, guys?
But you kind of have to have the parts lined up for that. They can't send out for an adapter. You know, we had basically a smart rear end ready to go.
We'll have it all queued up.
So that's kind of.
Also wanted to note that I got a message that Bill and Mark have left me a message, so I owe you guys phone calls, and it sounds like they're willing and ready to help out with EVCON as well. So thanks, guys. I'll be in touch shortly.
Bill and Mark who?
Bill Evans and Mark Chapman. Have not met them, so don't want to put the guys on the spot. Maybe they were calling for something completely different. Oh, Bill Allen and Mark Bishop.
Oh, yes. Mark's been here several times. Yes, we need all the help.
Any help any of you guys can provide, we
one you want to check
it.
on is Algeta, because he's always key
as well.
on the drag strip.
Okay.
He's the only one that knows how to work. We've actually got some
light
fairly exotic drag racing equipment that none of us know how to work.
Okay.
And so you'll need to have
Al, hope you're watching too. And ultimately we just look forward to putting on a good, fun event that, something that'll be memorable.
So if you have any ideas of topic, John Hardy will be back with the some battery information, and has been testing some batteries all along since last EVCON. And so he does some very long-term testing that's kind of interesting. And then I would hope that by EVCON we have the Tesla drive unit test bench, where we can do a full session and Q&A and so forth about that.
Right.
That I think will be kind of a central issue of it. Because I think
our main focus.
I think in the future the dream build,
if
you just want to dream, is going to have a Tesla Model S.
Right.
You can do some great cars with either the Siemens or the UQM, which are about the same power. The UQM is permanent magnet, a little smaller motor, a little bigger, heavier inverter, and the Siemens, of course, is a square motor, a little bigger, and then a little lighter inverter, and they both have essentially the same shaft on them, and so all that can be done, but for the high-enders, the magic car is going to have a Tesla drive unit in it.
Yeah.
It's just the way it is. And I'm just not going to back off of this until we've got a control unit that can basically drive it.
Yeah.
And
it's going to happen.
It's
going to happen.
As long as little girls plant trees 30 years ago.
Yeah.
All your drive unit belong to us. Because of wrecks.
Yeah. Hey.
And
I saw a whole bunch of them just the other day. I was, for fun, just looking them up, and
shit happens. And when it does, we'll be there with a wrench to pull that drive.
Sure.
And
don't tell anybody.
And hopefully work our way through the chargers and the DC to DC converters. They've got all kinds of neat equipment.
Great stuff. Hey, it's not the best car for nothing.
On the other hand, Elon, if you want me to shut up about all this stuff, I'll be happy to do so. Send your CAN bus DBC file to Jack Rickard, 601 Morgan Oak Street, Cape Toronto, Missouri.
Come on out and see what we're doing.
And I really won't have much to talk about then because it'll be over.
Yeah.
And so it's the definitions of the CAN codes that is the fun part of the puzzle, but also the stymie. And so we'll stay after
Modern day hot rodders.
I think that's an accurate description of where the future is for EVTV. And like I say, right now everybody's buying used Leafs. Things are kind of dry, but that will they'll get them, they'll drive them, and they're just a car.
Yeah. There's no satisfaction.
The next 68 Mustang done from a brand new steel body and built from the ground up with a Tesla drivetrain, that's the next dream.
Yeah.
And there's a difference between a car you drive to the grocery store and a dream.
Yeah.
And
guys, it's going to be everything.
Guys my age want
the car you wanted in high school.
The car you wanted in high school but couldn't afford.
Right.
The car
this time
you wanted
it's quiet.
when you had 3 kids and a mama son. And, that car didn't work for that.
Yep, that dog don't hunt.
And so you're at the time in life where the kids have gone away to college, or actually for most of us have kids going away to college, and time on your hands.
Or you got that son or daughter that you want to build a car with.
That's true. Well, now I got to tell you, I really thought that this would be the greatest thing for father-son build teams.
Or daughter, because my daughter would get right in on it.
And I pictured guys about your age with their 18-year-old son working on the thing. You need to go look at some of the photos of our early EVCons. We had 6 such teams in here one day at one thing, and maybe 8. Unfortunately, it wasn't quite what I saw.
It was...
all the sons
guys older than
were
you.
my age.
Right, guys, the dads.
And all the dads were in their 80s.
Right, they were the ones, supervising, watching.
Right. Well, I don't know who was doing what to who, but a lot of times at the end of the other end of life, where the reconciliation of all that went before can be most poignant. And I would almost burst into tears every time I saw these guys.
Right.
And we got them all together and made a photo, at one point of the father-son teams. But it wasn't what you're picturing.
Yeah.
It was 60-year-old guys with their 80-year-old dads.
Right, right. Well, my first car is a 56 Ford that my dad and I built from the ground up. So I was in a pretty unique situation that I grew up in a shop, so it was, kind of cool. And that was all the learning experience.
Took a 56 Ford now, and you and Dad made it into electric.
Yeah.
It'd be kind of a neat time.
Yeah. Well, I just did the other one a few months ago.
Oh, you did?
Yeah.
Okay.
So I've done 2 of those, and so I was kind of excited when you saw
was
that
it
55.
electric?
No, I did a ICE engine, but it was cool. Truthfully, I still don't mind the sound of a badass 3.8, but
you'll get over it.
Yeah. I definitely love the quiet.
Someday a guy will come pulling up in here with a Buick.
Yeah. What the hell? Get that
and
noisy,
in,
stinky thing out of here.
To do something with his oil pump or something.
Yeah.
You got a leak or something.
Right.
He thinks this is a garage.
Get that thing out of here.
And every time the conversation's just hilarious. He asks you, can you all fix my radiator or my oil thing's leaking or whatever it is? And we're like, no. Well, don't you all working on cars? No. And he's looking around
what are all these
the
cars?
The lifts and the tools and all this stuff. You don't work on cars here? We're a TV show. We don't know anything about that. But, whew, boy, does it smell. Get that out of here. Can you park that outside?
Well, and this was brand new, clean, so it didn't even drip, when I was done with it.
Well, we'll get you converted over to.
Oh, I've been bitten. I have been bitten by the EV bug, no doubt about it. So,
so that's we'll have a month of everybody out shopping for used rolling stock.
Yeah,
and that'll suck up a lot of their extra funds.
Yeah,
and then
we'll be here for you guys.
A used Leaf will take about a week for the new to wear off.
Right, the novelty will be over.
New anyway. Yeah. And you'll be buzzing around a Leaf thinking, man, every car you see, boy, I bet that would hold a bunch of batteries.
Yeah, that's exactly. I've been doing that for the last 2 years.
You get to where you eye every car.
Yeah, you can ask Rhonda. I'm just like, that'd make a great conversion. That'd make